Stella is standing at point A on the bank of a river that is 2.5 kilometers wide. She wants to reach point B, which is 15 kilometers downstream on the opposite bank. She plans to row downstream to point C on the opposite shore and then run to B. So we're going to make a sketch of this situation. So here is our river. And Stella's standing here on one side of the river at point A. And she wants to reach point B, which is 15 kilometers downstream on the opposite bank. So here we go. Here is B. And we know from A all the way to B here, it is 15 kilometers. And also that the river is 2.5 kilometers wide. So from here straight across, this is 2.5 kilometers. All right. So she's going to row downstream to point C on the opposite shore and then run to B. So she's rowing all the way here to C, and then she's running from point C to B. So we just made a sketch of the situation. Down here below it says that she can row downstream at a rate. So it's giving us a speed. And we know rate is related to time and distance. We know this from just the standard formula, distance equals rate times time. So if I wanted to isolate my rate, I can divide both sides by time, and I know that distance divided by time is my rate. So from this information, we can, let's move this down a little bit here. If we talk about the row rate, we'll do that right here. She rows at a rate of 4 kilometers per hour. So if we try to relate to this equation, we have our rate, which is 4, equals our distance, the distance we row. Well, we said that she rows up here from A to C, so that's our distance, AC, over our time. And how long she rows, we don't know, so we'll just call that time 1 here. All right, if we do follow the same process here now for our running rate, we can say we know that she runs at a rate of 8 kilometers per hour. And I can write that using that same equation as we did before. We can say 8 kilometers per hour is our distance that we're running, which is here, C to B, over the time we run. Again, don't know that, so we call it time 2. All right, now the last bit of this question says if her trip takes a total of 3 hours. Well, we could write another equation that's saying that the amount of time it takes rowing and the amount of time it takes running, that's T1 plus T2, is 3 hours. How far should she stand? How far from B should she land? How far from B should she land? So we're looking at the distance from B that she's landing. So this right here, what I drew in red, we can just call this X. So we can now replace our CB here with X. So we have 8 equals X over time 2. All right, so now we have distance in the terms of X here. Well, on our rowing rate, we can take AC and we can find the distance in AC with respect to X. From this information, we know that this distance downstream is 15 kilometers, and the distance from C to B is X, so this right here is 15 minus X. And I can now find the distance that I wrote by just using Pythagorean theorem, because I have a right triangle here. So that's just A squared plus B squared equals C squared. So we can say 2.5 squared plus, that's just 15 minus X squared, and that equals C squared. If I want just C, I can take the square root of that whole thing. So that distance there is from A to C. So now if I plug that into my equation, I have 4 equals the square root of 2.5 squared plus 15 minus X squared all over time 1. All right, so now here we are. 2 equations and almost two unknowns, we can rewrite this middle equation, time 1 and time 2 equals 3 hours, using our two equations. If we isolate our time, we have times, we can do 4 times time 1 equals the square root of 2.5 squared plus 15 minus x squared, divide by 4, divide by 4. So here's our time 1. And we can do the same thing on this side. Multiply both sides by time 2. We have 8 times 2 equals x. So divide by 8, divide by 8. So that means time 1 here, which is represented by 2.5 squared plus 15 minus x squared. That's time 1 plus time 2, which is x over 8. And that all equals 3. Now, we're not going to get too fancy. You're just going to put this into your graphing calculator. We have two equations here. I'm sorry, we just put this, we have two equations. We put this into y1, put this into y2. You find the intersection point. And I think we come up with something in the terms of, I want to say it's 6.74, somewhere around there. That's just a guess, kilometers. And that's what our distance is.